Hello, dear students. Welcome to today's session. So, this is a session 2 for real numbers. So, in this session, we will be continuing with the example questions. We will be taking with example 4, and then we will be starting with some questions from the exercises and a bit brief idea regarding the fundamental theorem of arithmetic, and more clarity will be given in this session. So, let's not waste much time. Let's get started. So this is an example for find the HCF and the LCM of three numbers 6, 7 and 120 using prime factorization method. So this is how we prime factorize for 6, 72 and 120. Right? When we write the factors, the common factors are 2 and 3. So the HCF is 6. For the LCM, 2 is here, so we are writing 2. 3 is here, we are writing 3, 2, 2, 3 and 5. When you multiply all of them, you get it as 360. So here we can't use this formula. HCF into LCM is equal to A into B. This formula is not used here. For a reason, this is only for two numbers, but we have here three numbers. So very simple. You can see, notice that 6 into 72 into 120 is not equal to the HCF into LCM. So the product of three numbers is not equal to the product of their HCF and LCM. So this is one of the important note point which we have to remember. Let us come to exercise 1.1. So the very first question here is express each of the following as the product of its prime factors. So 140 on the method of prime factorization like this. Give its factors. So 2 into 2 into 7 into 5 are its prime factors. So prime factors of 140 are 2 square into 5 into 7. Clear? Any doubts? Okay. Next, for 156, the prime factors are 2 into 2 into 3 into 13. Okay, 2 square into 3 into 13 are the prime factors for 156. Similar way, we will find it out for 382. The prime factors for 382 are 5, 5, 3, 3 and 17. 5, 765 times is 382. 5, 153 times is 765. 3, 51 times is 153. 3, 17 times is 51. 17, 1 times is 17. So henceforth the factors are 5 square into 3 square into 17. 5005. By the method of prime factorization, we can factorize it like this. 5005 divided by 5 gives 1001. 1001 divided by 11 gives 91. 91 divided by 7 gives 13. 13 by 13 gives 1. Therefore, the factors are 5 into 7 into 11 into 13. Clear? Okay. For example, question number 5. 7429. 17, when you divide 7429 by 17, you get it 437. When you divide 437 by 19, you get 23. 23 is a prime number. When you divide by itself, it gives 1. So 7429 can be expressed as 17 into 19 into 23. Okay, this note point is very important since the given numbers need to be expressed as the product of the prime factor. So in order to solve this problem, knowing the prime numbers is required. Very important. You should know what are the prime numbers. And do not forget to put exponents in case of prime numbers are repeating. So while I was telling for this question, I told it as 5 square into 3 square into 17, but I have not written. You have to write it like this: 5 square into 3 square into 17. This is how you write this. Rada. Clear? Yes, make a note of the note point. Please do pause the video and make notes. Question number 2. LCM and HCF of the following pairs of integer and verify that LCM into HCF is equal to the product of two numbers. We are doing a verification step over here. So, well, for the very first two numbers are 26 and 91. The prime factorization of 26 is 2 into 13. 91 is 3 into 13. Common factor is 13. So HCF is 13. LCM is 13 into 2 into 7, that is 182. Well, let's go for the verification step. First step is LCM into HCF, that is 13 into 182 will give us 2366. Okay, let's see if it holds good for the RHS. What is the product of the two numbers? Is 26 into 91 equal to 2366? Yes, they are equal. So henceforth, LHS is equal to RHS and it is verified. Clear? Coming to the next question, 510 and 92. The prime factors of 510 and 92 are 510. So 2 into 5 into 3 into 17 is nothing but 510. For 92, 2 into 2 into 23 is 92. So common factor, the highest common factor, that is HCF, is 2. So the LCM is 23,460 is the LCM. When you check for the LHS, the LCM into HCF, the time you get it, 46,920 as your answer for your LCM. So this is your LCM. Sorry, this is your LHS. Whereas for your RHS, 510 into 92 will also give you 46920. This is your RHS. So when you consider both, your LHS and RHS are equal, so hence we verify it. Clear? Clear? Next, moving ahead, we have 336 and 54. You know the method of prime factors. Find the prime factors. So we know what are the factors of 336. 3 into 2 into 2 into 2 into 2 into 7. 336, that is. For 54, 3 into 2 into 3 into 3. So we have HCF as 2 into 3, that is nothing but 6. And we have the LCM over here as 3024. So well, HCF into LCM we get it as 18144. So this is my LHS. Let's see for RHS. When you do the product of two numbers, that is 336 and 54, we are getting again 18144. This is my RHS. So clearly I can tell LHS and RHS are equal, so hence I verify them. This kind of question is pretty easy and easy to score, isn't it? Yes. Let's take a note point. HCF is always the product of the common prime factor raised to the least power, whereas the LCM is the product of the prime factor raised to the highest power. And well, remember this, HCF is always a factor of LCM. In the question, they have asked us to verify, so do not skip the verification step. The product of two numbers is equal to HCF into LCM. You have to write that as it helps in our cross verification also. Coming to the third question, so here we have three numbers. We have to find the LCM and HCF of three numbers by the method of prime factorization. Well, for 12, the prime factors are 2 square into 3. For 15, the prime factors are 3 into 5. For 21, the prime factors are 3 into 7. We can see all 3 is common in all three of them. 3 is common, so HCF is 3. LCM will be 2 square into 3 into 5 into 7, that is 420. So we have found HCF, we have found the LCM. Coming to the second question, 17, 23, and 29. So here all the three are co-prime numbers. What are co-prime? They are prime numbers. Okay, these are all co-primes. So 17 is a prime, 23 is a prime, 29 is a prime. So what is the HCF? Co-prime numbers are the numbers for which the HCF is always 1. Whereas the LCM is the product of the numbers itself. That gives me 11339. 11,339 as my LCM. Next we have 8, 9 and 25. So prime factorization of 8, 9 and 25 are 8 can be written as 2 cube, 9 can be written as 3 square, 25 can be written as 5 square. Whereas all these are not co-prime, but rather their HCF is 1 over here also. There is no common factor other than 1. So LCM will be 2 cube into 3 square into 5 square. That is nothing but 1800. So here there is a note point. Again, the note point is very simple. The HCF is the product of the common factor of all the three numbers raised to the least power. Remember this, least power, whereas the LCM is the product of factors of all you raise to the highest power. And HCF is always a factor of LCM. So to verify the answer, note HCF of ABC can be found out by taking two numbers at a time. So HCF of A and B and then B and C. If you take like this, when you find it out, again the HCF will be the same. Okay, this is how we verify it. Any doubts, anyone? Okay, so please do pause the videos and make running notes. It's helpful for you. So if there is any doubt, you can message me on this number. Your doubts will be cleared within 48 hours. Thank you. Have a nice day.